separate it.
Okay. So let's move on to contingency table. Section 3.4, we'll see how far we make it here. I might truncate some of this material off because contingency tables typically isn't that bad. So for students to understand. So, and we have been working on your homework, you have been working on some of these, and I think in class also we've had a couple of these in the past. This is a contingency table. So, right, using, we got speeding violations in the last year, no speeding violations in the last year, where they were using a cell phone or not using a cell phone kind of thing. So over here we have the totals, just pointing out, so this is the total of this row, adding 25 plus 280, I get 305, right, and so forth, and so on. So here we have the totals of the columns as well. So just kind of pointing out that these are the totals. I've had students, whether I give you the totals or not, it seems it goes both ways, right? We make mistakes with the totals and think that's part of the columns or rows kind of things and part of the contingency table, and do stuff with those numbers where those are just things we can use in order to help us calculate these things. So this group of 405 here, can we maybe explain what this group means in the study that we did?
No speeding violation.
So no speeding violation in the last year, and then somebody else give me what else? Yeah, so they're both, right? They're both of those. It's an and statement. 405 people do not use cell phones while driving, and they had no speeding violation in the last year. At least that's what they told you. Huh? All right, so let's go through some probability talks about this. So I'm going to move this up a little bit so we can, oops, try and do the next parts. Maybe we got to back this up. No, I can't back it up. Yeah, I'll move it higher when we get down there. All right, so we got totals here. So also, and we're trying to find the probability that the driver is a cell phone user. That sounds weird. That the driver is driving with a cell phone, right? It's not really a driver that uses a cell phone. That's pretty much everybody nowadays. So right. We all use cell phones. They're saying the driver's using a cell phone while they're driving, kind of thing. So the probability that they're using a cell phone while driving. How many cell phone users do I have? 25? That's it?
No.
300. Yeah, total, right? So these people had the speeding violation. They are all using cell phones while driving. Both those groups. So 305 people out of 755. Nice total, right? 757. Oh, that does not look like a 55 there. Let me refix that. So 55. So
Okay, so P.
using this total, right? So I have adding up those two, right? Or I can just use the total to take 305 out of 755. Next question. Probability. Find the probability driver had no violation in the last year. No speeding violations in the last year. We're talking about this group. 685 out of 755. And again, I'm not going to have you simplify that thing. I know there's a 5 you can divide out on the top and bottom, but there's no point, right? Your percentage or the decimal or something and use that. Or maybe we can leave this so if I need to work the fraction, I can work the fraction. So next case, find the probability the driver had no violation in the last year and was a cell phone user. No violation and cell phone user. No violation, 280. This group you're saying?
Yes.
So driver had no violation. So we have no violations in this group and cell phone users. So this is the group of and cell phone users and no violation. So we're saying 280 out of 755. Yeah, still out of the same total. It's only one condition where the total changes in the denominator in particular, and we're about to get there. Not on the next one, but the next one after. The given statement, yes, exactly. Yeah. Next one's an or. Driver is a cell phone user. Cell phone users. So Cell phone users uses cell phone. Or driver has no violation. No violation. So, or what?
So it'd be nine- would it be 9?
Yeah, it's an addition rule. You can literally use the rules we talked about before. There's also another way to do it, right? By taking the totals of all these groups. So, right, cell phone users,
305.
nope, the wrong groups. Sorry, that's not. Yeah, so 305. So you got this group and this group, cell phone users. No violation, this group or this group.
685.
So those three groups, 685
I believe it's 685.
out of
10.
755.
Oh, 7.
Over 755.
Oh, wait. Okay.
No?
Or? No.
It's not 6. Yeah, it's not.
55.
Because I'm looking at this, right? There's only one group that's not included in this, 45.
Yeah.
So should be 710. By the way, that 45, we just talked about the complement space, right? That's the only group that's not included in this or statement that we're making.
Wait, start over. I'm sorry. Yeah.
Yeah, so let me re-explain that.
Yeah.
No, the people. Yeah. Thank you, Lauren. That's
But are
a
we
better way
counting
to
both
explain.
groups and then subtracting what we double count? Like I'm
You can do it
confused.
2 ways.
Okay, well let's do it the first.
Can I do this? Cell phone users.
Right.
So we're calculating the probability that they're a cell phone using the addition rule over driver had no violation in the last year. And I'm going to subtract off the probability of cell phone user and no violation. So probability that CP, cell phone users. So cell phone users are 305
Right.
out of 755. My probability of no violation, no speeding violation is,
Can you bring it up?
oops, thank you.
But if all the denominators are the same.
I need to
why are we-
bring this up now.
I think that's it.
Seriously? No,
Yeah, that's a good idea.
on the book.
Alright, little track. Wow.
Is that going?
Here, put it on this.
There's not so. Thanks, Anthony. It paid off. All right, there we go. No, still can't see it.
Alright, it's close enough.
Close enough.
Yeah.
Get up in there. All right, so we can kind of see that bottom there. All right, so probability that somebody isn't a no violation is 685 out of 755, and the probability that they are a cell phone user and no violation is this
405 or 280.
280. Yeah, right.
I was just doing it one step at a time.
Which is 280 out of 755. We add these together, subtract off the 280 because we double counted them. Sorry, you can't see it. Are you getting these? Are we not getting these? Cell phone users? So if you're a cell phone user, uses a cell phone while driving. 305 people use cell phones while driving.
Right.
These two groups. Right? If you're no speeding violations, you are one of these groups. 685 of the time. Right? And then if we're saying or those, we can use this addition symbol, but we have to we double counted that 280 group. We counted them in both this column and this row. So if I'm using that formula.
I like
But
that
if you can
formula.
visually see 405 plus 305.
Yeah, there's no point in doing the formula. If you can see, right? Boom, 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 those three groups that we circled. Right, add them together, you get the total.
I just like to know how to do it the hard way in case it's not that easy.
No, yeah, sometimes you want to know both
Sometimes
ways.
there's decimals
That's
and-
definitely why I went with what Laura was saying. Right? I like that question. So either way you do it, though, you get that 710 out of 755. Okay. Let me do it this way. I'm gonna have issues with this one. Since I have extras here. I'm gonna do this last one like this, and then did I cover it up too fast?
It's okay, I'll give it.
It's on the video.
All good. I know, right?
So, all right. So the last one, we got that given statement, right? It seems to be a big concern. So, cell phone users, were cell phone users given the driver had a violation in the last year? So given the driver had a violation in the last year, how many drivers do we have a violation in the last year?
25.
So how many drivers do we have that have a violation in general in the last year? So I'm asking for the second part, 70 total. That is our denominator. All right, so we have 70 total. Drivers had a violation last year. This is 70. Given driver had a cell phone user. Driver's a cell phone user, but we're not looking at both anymore because we're given these 70. We're given that somebody is from this group of 70 people, and they have that they drive with a cell phone while using a cell phone. We no longer have this group. That group is gone from our list of population. So we have how many people that use a cell phone while driving?
We're 70.
Trying to list it out a little bit easier to see. So I got 25 people in this group given, which means essentially this division divided by 70 people in the other group. But I'm going backwards. I'm starting with what I'm dividing by to try and find that group of people that I'm given. Help you point it out. Can I go it the other way? Yes, we can do it the other way, no worse. You want to see the formula? So over here, I'll do the formula. Formula, we're looking for P of
Whatever.
cell phone users. Yeah.
Yeah, I
So
can
CP given no violation. Driver has had a violation. So V.
Yeah, violation.
We're looking for that statement, which is equal to, need some help. We haven't talked about this equation today. P of CP. There's a V involved at the top. Oh, you can't see. What goes in between those? CP and V. Sorry, that's a parenthesis. Not an or. Yeah. And divided by P of V.
Oh, right, because we copy the one that's on the end and put it on the bottom. Gotcha.
There's my formula, so I just need those two probabilities to be able to calculate this given condition. All right, this is another formula that should go on your cheat sheet as well. So P of CP and V. CP and V. I might need to get rid of this. Let's see. So CP and V. Where's CP? CP uses cell phone while driving. CP and violation. No speed. This is the 25. So we got 25 out of 755 is that top probability. Whereas the probability that they had a violation in the last year is 70 out of 755, which if I do the math, those denominators will cancel. 5 out of 70. So the formula works. Just depends what you see and what you want to do. Okay? Just got to find the right groups there for contingency tables. Uh-oh, there was one more question, yeah. So, right, exactly. Oh, crap. There was one more question from the stuff. So let me do this so we can see the table there. And the last question, which is another given condition. So given they were a cell phone driver, so given division, how many not cell phone users do we have? Not cell phone users. 450. So we're given they're not a cell phone user. Another way to think about it. Whoops, not a cell phone user. We get rid of the other group.
Right.
The cell phone users, all driving. Where our population is now this group of not cell phone users. We're no longer thinking about the other groups. So, how many of those do I have that had no violation last year?
4 or 5.
No
Wait,
speeding
40.
violation last year. So 405 out of 450. Whatever that is. So. Yes, we can still use the formula when it would work. Okay. Let me try that on your own. I do like going over both for these problems because, right, that helps. These given conditions usually cause some confusion. All right. So let's see how fast we can go through this example 2. I got 10 minutes. Oh, I can probably do it. Except it goes on for 2 pages. Never mind. So, all right. So here we have a contingency table, but I've got some blanks on it. So we're just trying to see if you understand what a contingency table means and how we can find the results. For instance, there's one place I can find, there's a couple places I can find pretty easy here.
Yeah, definitely.
So, can I find this one?
Yeah, absolutely.
Because I have a total, right? So 16 plus whatever this male group is should equal 41. So 25. So also this group on Mountain Peaks, females 11. So we add up all 3 of those, it equals 45.
Yes.
If I add up all 3 of these, it should equal 55. So that should be 16. 16, sorry, I thought you had 60 at first. 16. And now we can just add and get the totals. Right, so, what? 34, 25, and 100, because we're out of 100 hikers this time. Take it off this. Don't forget your books. So we completed the table. Next part are the events being female and preferring the coastline independent events. So being female, so probability of F. All right, we're talking about. So is that what we're talking about? What are we talking? And we're also talking about the preferring the coastline. So I guess I can say that P of C. So P of coastline. That's a parenthesis C. I think the other day when I was doing it in my other class, everybody was like, "Oh, is that a CC? What is that?" I don't get that one. Right? It's a parenthesis.
You did that, it was here.
Yeah, it was here. Oh, dang it. So I'm looking at these probabilities, but I really don't want that probabilities. I want to think if these are independent events, and we have a couple statements. If I had P of F given C, for these to be independent, then this would mean it would equal P of F. So I'm just rewriting the formulas in terms of my variables that I have. Right? And so if I had P of C given F, my probability, then this would equal the probability of C. So if one of these are equal, one of these scenarios are equal, then we have independent events. So we're asking the question, are these equal? Right? And really all you have to do is show one case. So we pick one and we go for it, whatever's easiest for us to figure out. So let's pick one. P of F given C. So P of F given C, so P of F given C, so we're given that C already occurred. So if we're doing P of F and C is equal to C already occurred, so you get rid of the rest of these. Ignore the rest of those. See if I can cover them up somehow. There you go, coffee. Bam! No. There we go, covering them up. Yeah, that looks gross. Turn that around, still looks gross. Oh well. Oh, here's chalk. Why didn't I use the chalk? That's much easier. So